In this video, we're going to start chapter 10, lesson 1, and it'll be an introduction to parabolas. In chapter 10, it's going to be our chapter on conics. So we'll cover parabolas, hyperbolas, circles, and ellipses. So let's first define what a parabola is. And a parabola is the set of points in a plane equidistant from a fixed point and a fixed line. And this is what's new to us. We actually did parabolas back in chapter 3. Remember, those were the U-shapes and the upside down U-shapes. So what's new to us is going to be the fixed point, which is going to be called the focus, and the fixed line, and that's going to be called the directrix. Both the directrix and the focus are going to be equidistant from the vertex. So right here is a picture of a graph of a parabola, and this is what we're used to seeing back from chapter 3. Again, what's going to be new to us is going to be this focus point that we're going to learn how to come up with the coordinates, and this directrix. And the directrix is going to be an equation of the line. We saw back in chapter 3 the axis of symmetry, and we also saw the vertex. We also talked about the direction of the parabola, whether it opened up or down. However, what we're going to see in this chapter are going to be parabolas that are going to open up left and right. So again, the focus point is going to be a point that is inside our parabola. So it's inside our U-shape or our upside down U-shape or inside the C. So it'll be inside the parabola. This directrix is going to be a line that's outside the parabola. So it's going to be sort of like on the back side of it. Our focus point is going to be an ordered pair. We're going to learn how to calculate a p-value, and the focus point will always be 0, p. Our directrix is going to be the opposite of p, and again, this is when our parabola is opening up and down when we have an x squared term. So our directrix is going to be an equation of the line, and it's going to be y equals opposite of p. Now, when our directrix, or when our parabola opens left and right, then this time our directrix is going to be an equation. It'll be x equals negative p. Over here, again, like if I wanted to figure out my focus point, again, it's going to be, again, it's going to have the p-value. So these are examples where we have a y squared, and these two right here is what we're used to seeing, and in our equation we're going to have an x squared. So we're going to have one of our variables will be squared, and then the other variable will not be. So the first thing we're going to talk about are parabolas with the vertex that's going to be sitting at 0, 0. And we actually did these in chapter 3. So for example, when I had the equation y equals x squared, we know that our vertex is here at 0, 0, and then this was like our parent function, and we had the ordered pair 1, 1, 1, negative 1, 1, and our u looked like this. Now, as soon as I added something, so let's say I took that parent and I added 3, remember that would have been a shift 3 units up, 1, 2, 3, and then our vertex would have been sitting here. Also recall, we also saw things like this where there was a number in front of x squared, and then this told you that either your graph got wider or skinnier. So also the number in front of x squared, remember if the number in front here was positive, it was like a positive person, so it was smiling, If it's negative, it would be frowning. So the number in front of x squared told us whether our parabola opened up or down. So we're going to see a new form. This is what we were used to. Now the way that our equations are going to be, it's going to be x squared equals 4py, or if it's going to open left and right, look like a letter C, it's going to have the variable y will be squared. And again, this 4p is always going to be in front of your non-squared term. Now, just like before, if this number in front here is positive, then we know it's opening up. If it's negative, it's going to be down. And then the same thing here. If it's negative, it'll be a backwards C. If it's positive, it's going to look like the letter C. Now, the p-value, and we're going to be calculating this, is going to be the distance that the focus and the directrix, how far away from that vertex those two things lie. Focus is a point, directrix is going to be a line. So again, this will be a point, this is going to be a line, so it's going to be an equation. Let's go ahead and look at our first example. So notice here, I have an x squared. Notice it's in this form. X squared is equal to 4py. Remember, the number that is in front of y represents the 4p. So in the homework, it's going to ask you to find the value of p. So what I'm going to do is I'm going to take whatever number is in front of the non-square term, and in this case it's 8. I'm going to set that 8 equal to the 4p. Divide by 4, and my p-value is 2. This p-value is going to be the distance that we're going to travel, or the distance away from the vertex that our focus point is going to be, and our directrix, which again is going to be a line. So let's go ahead, and when you're doing the homework, they're going to ask you to find the p-value. They're also going to ask you to find the focus point, the directrix equation. It's going to ask you to find the vertex. And then it's going to ask you to find an additional point on your graph. And the way that you're going to get that additional point is you're just going to plug in values for either x or y into your equation. And you can choose whatever numbers you want to plug in. A lot of times it's easy to find the x and the y intercepts. That's only going to work when our vertex is not going to be at 0, 0, because obviously then that's going to be our x and our y intercept. So for this problem, notice my vertex is going to be at 0, 0. So I've already found that part of the problem. Now to find my focus point, what I'm going to do, well, let's graph the parabola first. So I have the vertex. To find an additional point, I'm going to plug in a value for either x or y. I'm going to actually plug in x equals 1 into my original equation. So once I plug it in, I get 1 squared is equal to 8y. 1 squared is 1. Divide by 8. And the y of this coordinate is 1/8. So additional point could be the ordered pair 1, 1/8. So I'm going to go ahead and graph this. I know it's a little bit hard to graph 1/8, but let's go ahead and we'll just put it a little bit above the x-axis. Now, if you recall back from chapter 3, remember there was always this axis of symmetry that went through the vertex. So in order to get the left side of my parabola, notice this is one space away. I can go one space away this way and then put it again directly symmetrical on the other side. So my parabola is really wide here, looks like this. Now, to get the focus point, I'm going to be using my p-value, which is 2, and I'm going to add that when it's opening up and down. I'm going to add that p-value to my y of my vertex, because remember, you're shifting it 2 units away from that vertex. So my focus point is the order pair 0, 2. That's your focus. Then the directrix, it's going to be the opposite of p. So my directrix equation is y equals opposite of p, -2. So if I come down here, my focus, I'm sorry, my directrix line is right here. So this is my directrix. And again, the equation for that directrix is y equals -2. So you're going to need to find the p-value, because you're going to use that p-value to find your focus point, your directrix. You also need to find the vertex, and then one additional point that is going to be graphed on your parabola. Now, sometimes when it's these crazy fractions, you'll just approximate where you're going to put it, but then label it and just tell me what order pair you've graphed here. And then this one will be the -1, and then comma 1/8. Let's try the next one. This time I've got a y squared term. My vertex is still at 0, 0. So my vertex is still here at 0, 0. Now what I'm going to do, again, remember it's in this form. So y squared equals 4px. So remember, 4p is represented by the number in front of x. So to find the p-value, I'm going to do 4p equals -28. I'm going to divide both sides by 4, and my p-value is -7. So now I need to find an additional point so I can graph my parabola. Now, as soon as I see I've got a y squared, this tells me that my graph is either going to be this or this. Because this number in front of the non-squared term is negative, this tells me it's a backwards C. So I'm going to go ahead and find an additional point. Now, this time, before I plugged in a value for x, let me plug in y equals 1. Again, it doesn't matter what you plug in. So if I plug in y equals 1 and I square it, and now I get 1 equals -28x, divide by -28, and I get x equals -1/28. So now the order pair that I'm going to graph, again, this is kind of hard to graph, but we're just going to label it. So we're going to graph our vertex, which is right here at 0, 0. And then I'm going to graph the order pair, -1/28, comma 1. So if I put little numbers here, so again, I can make it go up to 1, -1. So my point will be right here. It's going to make it really wide. I can use my line of symmetry here, and I can make the other point the same distance away. So here is the graph of my parabola. Again, somewhere on your graph, label your point. So -1/28, comma 1. You really only need to find one other point. I could also do this one, which is this point here. Now I need to find my focus point. Now this time, when you have a y squared, you're going to take your vertex and you're going to add your p-value to the x. So my p-value is -7. So my new coordinates for my focus is going to be the order pair -7, 0. Again, remember, it's inside your parabola. So if that's 1, 2, 3, 4, 5, 6, 7, right here is going to be my focus point. And it's the order pair -7, 0. Remember, your directrix is going to be the opposite of P. So P is -7. So my directrix here is going to be +7. And again, when your y is squared, your directrix equation is x equals. So if I come over here and go 2, 3, 4, 5, 6, 7, then I can draw in my directrix. Graph that line. And again, it's usually behind your U, or your, in this case, your backwards C. So here it's super wide. So again, we found the vertex, we found the p-value, we found the focus point, we found the directrix, and then we found an additional point for our parabola. Let's try another one. Now, if you realize, let's flip this around, this is the standard form that we're used to. However, in this chapter, we're going to be working on getting our equations into this form, either x squared equals 4py or y squared equals 4px. You want your x squared or your y squared to be all by itself. So what we need to do is work on isolating the x squared. So right now I have 4x squared equals y. I need to get x squared all by itself. So to do that, I need to divide both sides by 4. And now I have x squared. And now I need a 4py value, or just a 4p value. So what I'm going to do is, instead of leaving this as y over 4, I'm going to make this 1/4 y. Now I can grab my 4p value. So now here is my equation, but to find the value of p, I'm going to take 4p and set it equal to 1/4. My goal is to solve for p here. Now I can do two things here. I could do it traditionally, like I'm going to divide both sides by 4, and now I get p equals, and what I'm doing here is 1/4 divided by 4. If I do a keep flip change, I get p is 1 equal to 1/16. Now another thing you can do when you're solving this green equation, you could also solve it as if it's a proportion. Put a 1 under the 4p and cross multiply and divide. So you would get 16p equals 1, divide by 16, p equals 1/16. Another way that you could solve this is just multiply by the reciprocal. So again, just showing you multiple ways of doing this. To solve for p, multiply both sides by the reciprocal. This cancels, and again, I'm left with 1/16. However you want to isolate p. For me, it might be easier to do the proportion, but that's up to you. All right, so now I found my p-value. So remember, we're looking for the focus, and it's a point. We're looking for the directrix, the vertex, and an additional point. So we already know our vertex is at 0, 0. We could also figure out our focus point. Because our graph, we've got an x squared, we know it's opening up and down. We're going to add the p-value to the y of the vertex. So here's my vertex. If I add 1/16 to the y, my new focus point is 0, 1/16. The directrix, remember it's an equation and it's opposite of P. To get the additional point, pick any number you want and plug it in. So I'm going to take my original equation or the rearranged, either way. So let's say we take the original, and let's say we want to plug in x equals 1. So 4 times 1 squared equals y. 4 times 1 squared is 4 times 1. So my order pair is 1, 4. So if I go to graph this, my vertex, my order pair 1, 2, 3, 4. I can use my line of symmetry, and here's my parabola. I need to graph the focus point. So my focus, again, 1/16, kind of hard to graph. So maybe say it's right about here. And then do the same thing for the directrix. 1/16 away from that focus point. So we found everything we needed. Our additional point here is the order pair 1, 4. Again, everybody's additional point may end up being different depending on what you plug in. So you need to find these 4 things. However, to find them, you really need to find the p-value. Let's try one more where the vertex is still at 0, 0. This time we have a y squared. Again, remember we want it in this form, y squared equals 4px. So I need to isolate y squared. So I'm going to divide both sides by 8. Y squared, again, I'm going to make it 1/8 x, because again, remember this 4p is equal to the number that's in front of the non-squared term. So 4p equals 1/8. Again, I think it's easier. Let's solve this as a proportion. Let's just put a 1 under here. And now let's just do the cross products. So I'm going to do 1 times 1 is 1. 4p times 8 is 32p. Divide by 32. And p is 1/32. Now, when it's a y squared, again, if this number is positive, you know it's going to look like a c. So far, I can put my vertex here. And I know it's going to be a c value. So now, let me go ahead and plug something in. So notice in my equation, if I use the rearranged one, let's say I want to get rid of the fraction. So let's say I make x equal 8. So if I do y squared equals 1/8 times 8, y squared equals 1. So y equals, when I square root it, plus and minus 1. So I could graph the order pair 8, 1 and 8, -1. Let me go ahead and 1, 2, 3, 4, 5, 6, 7, 8. And then I can put a point here and here. So here is my C shape. It's a sideways parabola. So far I have found the p-value. I have found my vertex. It's at 0, 0. My additional point are these 2 order pairs. You only need to list one. Now I need to find the focus and the directrix. Remember, we take the vertex. We're going to take that p-value and we're going to add it to the x. I'm going to add 1/32. So my focus point, 0 plus 1/32 is just 1/32. And then the directrix is going to be the opposite of p. And again, it's an equation, so it's x equals -1/32. So these are all the things that you need to find when you're working on this. Remember, you always need to work on first isolating the square term. All right, so these 4 examples that I just did, all of the vertexes were located at 0, 0. Now we're going to look at some graphs where the vertex is not at 0, 0, not at the origin. So just to review, if you recall the vertex form of the equation from chapter 3, remember the vertex is always an order pair, but when we introduce this vertex form of the equation, remember our vertex was called H and K. So the H is the X of the order pair and the K is the Y of the order pair. We're now going to transform the equation into these two. So what we're doing is we're going to manipulate that equation we saw in chapter 3, and you're going to memorize that y minus k equals a times x minus h squared. Notice the x is always with h, and notice here, and the y is always with k. Same thing here. No matter whether or not it's your x squared, or the x is squared, or the y is squared. So again, when the x is squared, we know that it's going to have a vertical axis, and when the y is squared, it's horizontal. So let's go ahead. Again, remember h goes with x and k goes with y. So let's try an example of this. And we're going to be pulling the vertex out. We're going to pull the h and the k. When we pull our h and k out, remember it's opposite of what you would think, because look at your equation. Part of it is got a subtraction sign. So what you would think is coming out is opposite. So again, this is going to be examples where the vertex is not at the origin. It's going to be at the order pair HK. So on this first example, here's my H, here's my K. I'm going to pull it out, and again, it's opposite of what you would think, because the subtraction sign here is part of the formula. So what comes out is positive 3, and what comes out of this is negative 2, because what's in there is negative, negative. So first thing you're going to do is find the vertex, and you just pull out the h and the k. Now again, notice here is our 4p. It's going to be the number that's in front of the non-squared term. So in this case, our 4p is equal to this 4. So 4p equals 4, divide by 4, and my p-value is going to be 1. So remember, this p-value is the distance that the focus point is from the vertex and the directrix line. Now, I also need, so now I've found my p-value, I found my vertex, I need to find an additional point. So I'm going to take my original given equation, and I'm going to plug in. Now, probably what might be easy to find here is I'm going to find my y-intercept. So remember, to find a y-intercept, we set x equal to 0. So I'm going to plug in a 0 here. 0 minus 3 squared equals 4 times y plus 2. Negative 3 squared, I'm going to distribute. 9 equals 4y plus 8. Subtract the 8. 1 equals 4p. Divide, 4y. Divide by 4, and the y of my additional point is 1/4. So the order pair, my additional order pair, is 0, 1/4. So let's go ahead. So here's my additional point. And I can use my axis of symmetry. So let's graph the vertex. So So 1, 2, 3, and then -2. And then I can graph my additional point, which is 0 and 1/4. So I'm going to come over here. Now, remember you have your axis of symmetry here. So I can use that line of symmetry to get another point. So notice this point right here is actually 3 away. 1, 2, 3. So over here I could go 1, 2, 3, and then put another point to get the other half of my U shape over here. And again, it's kind of wide. So far I found an additional point. I found the vertex. Now I need to find the focus point. Remember, the focus point will be inside that U shape. So what I can do here is to find the focus, I take my vertex, and whenever it's got an x squared, I'm going to add my p-value to my y. So then this gives me my new focus, or my focus point is 3, -1. So right here, let me do it in, I'll do it in blue. And then your directrix is again an equation of the line. It's the same distance away from the vertex that the focus is. So notice your directrix is going to be down here. It's 1 away from the vertex because your p-value, it's opposite. So 1 away, and your directrix equation is y equals -3. So you're going to find your directrix equation, your focus order pair, your vertex, and your additional point. And you're also going to graph it. Let's try another example. Now, we need to get this into the appropriate form. So we want to have here x minus h squared equals 4p y minus k. So here, notice my x is right here. This is the square term. So I need to get rid of that 4. Or -4. So I'm going to divide both sides by -4, and I get x plus 3 squared. And again, let's make it so it's a number in front. So my 4p value is this -1/4. So I need to find p, so I take 4p equals -1/4. Again, I think it might be easier to treat it as a proportion, so put a 1 and cross multiply. 16p equals -1, divide by 16, p equals -1/16. So let's go ahead and we need to find an additional point. Let's find the y-intercept. Now, when your graph opens up and down, it's probably easier to find either the y-intercept. It may not have an x-intercept. So just sort of take a look. So I'm going to set x equal to 0. So I'm going to use my rearranged. Doesn't matter which, but let me go ahead and use this one. 0 plus 3 squared equals -1/4 y minus 2. And then I can distribute -1/4 y is equal to +1/2. And then 9 equals -1/4 y plus 1/2. I could actually clear my fraction. I could multiply everything by a 4 and get 36 is equal to negative y plus 2. And now I can move the 2 over. 34 equals negative y. Divide by negative 1. Y equals a negative 34. So my y-intercept is going to be the order pair. It's way down there. So let's go ahead and let's pull your vertex out too. So remember, this is H, this is K. So my vertex is the order pair negative 3, opposite of what you would think, comma 2. So over here, 1, 2, 3, negative 3, positive 2. And then I'm going to graph and say, this will be my y-intercept, 0, negative 34. Again, I could use my axis of symmetry. So I could draw this line of symmetry. So to get a point on this side, this is 3 away. So I could go 3 away on this side. So then your graph would look like this. And then the focus point is going to be inside the parabola. So we could say that if we need to label this other additional point, negative 6, negative 34. Now to find my focus point, I'm going to take my vertex, which is the order pair negative 3, comma 2. I need to use this p-value. And what I'm going to do is add it to the y. I'm really subtracting it. So my focus point becomes negative 3. And then if I do common denominator, 32 over 16 minus 1/16, I get 31 over 16. For the directrix, remember, it's an equation of the line. So here we're going to do 2 plus 1/16. So my directrix is going to be y equals 2 and 1/16. If you want to make it improper, 33 over 16. So we can go ahead and graph it. Again, it's kind of hard to graph. So maybe right there. Let's do a different color. And then the directrix is on the other side here. And this is at y equals 2 and 1/16. So this is your directrix. This is your focus, your vertex, your p-value, and then either this additional point or this. No, that's, yeah, either one. This is also the y-intercept. Let's do one more example and then we're done. So notice this time it's already got the y-squared term isolated. Remember, this is your 4p. So 4p equals 24. I'm going to divide by 4. And p equals 6. Let's pull the vertex out. Remember, this k goes with y, h goes with x. So my vertex is going to be at the order pair 3, comma 2. So what I'm going to do here, since I'm a y-squared and my graph is a c, notice that my vertex is already here at 3, 2. So 1, 2, 3, 2. If I know my graph is this, what I'm going to do is I'm going to look for my x-intercept. So instead of finding the y-intercept, because already I know it's not going to go back that way and touch the y-axis. So for my additional point, I'm gonna find the x-intercept, so I'm gonna set y equals 0. To find the intercepts, that's usually an easy thing to do because you're plugging in a 0. So let me take my original equation, square the -2, distribute the 24, move the 72, divide by 24, and I end up with 19/6, or 3 1/6. So my additional point is going to be 3 1/6, comma 0. So 1, 2, 3 1/6, comma 0. So again, it's going to be really wide. You can use your axis of symmetry to get another point over here. So 2 away, 1, 2, and 1 straight up above. So now we need to find our focus and our directrix. So we're going to be using the p-value. So my vertex is 3, 2, but to get your new focus point, we need to add the p-value to the x, so we get 9, 2. That's your new focus point. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, and it's right here. So this is your focus. And again, label these points. It helps. 3 1/6, comma 0. Tell me your focus is 9, 2. And then to find the directrix, we're going to subtract it from the x, and we get x equals -3. So here is my directrix, x equals -3. So again, you're going to be finding the p-value, the focus point, the directrix equation, an additional point, and the vertex. So just make sure you read the directions, and you're also going to graph. And your homework for this first part of lesson 10-1 is 19 through 30 all. Some of them you're going to have to graph, and you're going to also have to list everything that I've covered today. And then we're going to be completing the square again, and we're also going to be writing equations. All of this is going to come from section 10-1.